Hello there, and welcome back to Maths. In the last video, we introduced the ideas of infix, prefix, and postfix notation, which were these very interesting ideas that basically allowed us to change the way we write mathematical expressions, but change them in a way where we don't need order of operations anymore. And we saw this connected to the Polish logician Jan Łukasiewicz, and kind of the big idea that he had with this. So today we're going to get a little more comfortable with these ideas by just practicing doing some math in these notations and also converting between the notations. So on the screen I'll have some problems for you to try out. Try them by yourself first, and then we'll get into them together. Question 1. Alright, so question 1 says evaluate the following expressions in prefix notation. And the big thing we need to remember with prefix notation is to always make sure that we evaluate the expressions from right to left. So we always evaluate the rightmost operations. Alright, so for A, we've got this expression here. And we're going to just evaluate one operation at a time. So we start with the multiplication, which applies to the 7 and the 9. 7 times 9 is 63. Next up, we're going to be evaluating this subtraction statement here, which is 5 minus 63, which is negative 58. And the sum of negative 58 and 4 is negative 54. Alright, part B. So the rightmost operation is this multiplication. So 5 times 3, that is 15. Next up, we're going to do this sum here, which is 19. Then we'll do this exponentiation. So that's 11 to the power of 2, or 11 times 11, which is 121. So now we're doing 121 minus 19, which is 102. Alright, and last one for this question. So again, the rightmost operation, we evaluate this plus, and that's affecting the two numbers to the right of it, so the 4 and the 1, and 4 plus 1 is 5. Okay, next up we have this division affecting the 10 and the 5, so 10 divided by 5, we know that's 2. Next we have 2 plus 2, which is 4. And lastly, 4 to the power of 2, which is 4 times 4, and that's 16. Okay, so for some extra practice, make your own expressions in prefix notation, and then go ahead and evaluate them. Question 2. Alright, so question 2 asks us to evaluate the expressions in postfix notation. And for postfix notation, kind of the reverse of prefix notation, we need to always evaluate our expressions from left to right, or we always evaluate the leftmost operation. Okay, so in this case, the leftmost operation is this exponentiation, and that affects the two numbers to the left of it, so the 5 and the 3. So 5 to the power of 3, that's 5 times itself 3 times, 5 times 5 times 5. If you work that out, you will get 125. Next up, we have this subtraction here. So we do 125, subtract 100, and we get 25 out of that. And now we're just left with this simple statement of doing a division on 25 with 5. So 25 divided by 5, we get 5 as our result. Okay, so this one's pretty long, but we're just going to do it as normal. So we just evaluate things from left to right, so that's starting with this addition. So we do 7 plus 5, which is 12. Next up, we have subtraction. So even though we produced this 12, the subtraction affects the two numbers to the left of it, so that's this 3 and the 2, so we're leaving the 12 alone for this step. So 3 minus 2, we get 1 from that. Alright, so now the next step is we can look at this 3 to the power of 2, right? Because the exponentiation is our next leftmost operation. And 3 to the power of 2, that's 3 times 3, which is 9. Next up, we have the subtraction, so 11 minus 9, that's going to give us 2. Now we can focus on this multiplication. So 1 times 2, that gives us 2. And lastly, 12 times 2 will be 24. Alright, so a bit longer, but again, it's the exact same process. And let's do the last part. So this one's maybe a little more stylistic. We're separating completely all of the numbers from the operations, but it's going to work out the exact same. So we start with doing the subtraction. That's 9 minus 9, which is 0. Okay, next up we have addition, so 5 plus 0, which is 5. Next up, we have multiplication, which will be 6 times 5. And then we do 120 divided by 30, which will be 4. And lastly, we have 10 to the power of 4, which that's 10 times itself 4 times, which is going to end up being 1 with 4 zeros after it, which is 10,000. All right, so hopefully you're more comfortable with postfix notation now, evaluating expressions within it. But if you need some extra practice, make your own expressions in postfix notation and then evaluate them. Question 3. Question 3 asks us to convert the prefix notation expressions from question 1 into infix notations. So what we're going to do is we're just going to kind of consider the order in which everything's done. And that is done by, again, moving from right to left with these operations. So the first thing we do is going to be doing this 7 times 9, right? So in infix notation, we know that looks like 7 times 9, like this. And then the next piece is this subtraction, right? So the subtraction is going to be the difference between the two numbers to the right of it, which is going to be this 5, and the result here. So that is going to be this part right there. So we do 5 minus this result. So we do 5 minus the 7 times 9 like that. And we don't need parentheses around this because multiplication happens before subtraction with our standard order of operations, which infix notation abides by. And then lastly, we do everything plus the 4. So we can write that like this. Okay, so this would be our answer, our expression written in infix notation. All right, so for this second part here, what we're going to do is same thing. We always start with the rightmost operation when we're dealing with prefix notation. So we're going to just work through how we would have evaluated this and translate that into what it would look like in infix notation. So the first thing that we would do is do this multiplication here, right? Do this 5 times 3. So let's write that down, 5 times 3. And then the next thing is we do this addition. So that combines the two numbers to the right of it, which is the 5 times 3 we just got, with the 4. So we do 5 times 3 plus 4, like so. All right, afterwards, we have this exponentiation. So what that does is it combines these two numbers, right? It combines the 11 and the 2, because those are what are to the right of it. And it'll combine them by doing 11 to the power of 2. So we can write that like this, or we could write it with the 2 kind of in the superscript of the 11. But this maybe is a little closer to infix notation because infix notation emphasizes that the operations are always kind of in between the two numbers they're combining. So this is more infix notation-esque than just putting the 2 in the superscript, in my opinion. And lastly, we do subtraction. So that's going to combine everything from here, and we're going to subtract off everything from over here, right? Those are like the two numbers to the left of the subtraction. So we just put a subtraction sign there. But we need to make sure that we are putting parentheses here to ensure that we're subtracting off this entire statement there, right? So this would be the result. So this would be the expression in infix notation. So to start with, we have the 4 plus 1. That's the first thing we're evaluating, right? So let's write that down right here. And the next step is this division statement right here. So this division is applying to the 10, and then the result from this 4 plus 1. So we're going to be doing 10 divided by the result of the 4 plus 1. But to ensure we're actually dividing by that and not just the 4, we need to put these in parentheses, right? Because we need to prioritize the addition happening before the division. All right, so that was the second step. The third step is to add on this 2. So we can just simply add a 2 because that's going to happen after the division part. And then lastly, we raise everything to the power of 2. Right? Because this exponentiation is taking this result here, right? That was the third step. So that's all of this right here, and raising it to the power of 2. And again, we need to use parentheses because all of this needs to get calculated first before we raise it to that power. So this is our expression in infix notation. All right, part B asks us to convert the postfix notation expressions from question 2 now into infix notation. So here we evaluate from left to right, or we evaluate the leftmost operations first. So the first thing we would be doing is 5 to the power of 3. So writing that in infix notation, we get that statement there. And then afterwards, we're doing the subtraction. So that's going to be this result minus the 100. No parentheses necessary because exponentiation comes before subtraction. And then lastly, we have division, where we take this entire result here and we divide it by the 5. But this needs to be in parentheses because we need to ensure that this is all calculated before the division step. All right, we're back to the long boy again. So again, we just start by doing the addition. So we have 7 plus 5. And then we also have a statement with subtraction. That's 3 minus 2. Now, this isn't touching the 7 minus 5 piece right now, right? So let's just leave a little bit of space in between them, and we will write the 3 minus 2 separately, and we'll see how they get combined later on. All right, afterwards, we have 3 to the power of 2, as written right here. And once again, that's completely separate, right? So let's write that kind of separately from these. And again, they're about to get combined. 11 minus this result of this 3 to the power of 2. So we're actually going to get 11 minus that. So that is our 4th step. And then our 5th step is to do some multiplication. So that's going to multiply the 2 numbers to the left of it, which is this result from the 3 minus 2. So that's this piece right here, with the result from this 11 minus 3 to the power of 2. So that's this piece right here. And we are multiplying them. And parentheses was necessary because both of these statements involve a subtraction, which comes after multiplication normally. So to prioritize them, we needed parentheses. So that was this step right here we just did. And now lastly, we're doing the multiplication of what we had from step 1 with what we got from step 5. So that's going to be the 7 plus 5 times this result right here. So this is our expression written in infix notation. So we're going to start by evaluating the subtraction. So we have 9 minus 9. Then we're going to add on the 5. So that's the second part. So we can do 5 plus 9 minus 9, or we could do plus 5 at the end as well. It doesn't really matter the order in which we do these because it's just addition and subtraction. Now what we need to do is we need to multiply this whole thing by 6. But we need to make sure this is in parentheses because step 2, that involved subtraction and addition, right? But that comes after multiplication in order of operations. So in order to prioritize it, we need the parentheses. All right, for our 4th step, we need to do 120 divided by all of that. So we need to do 120 divided by this result right here. That we need to put in parentheses, otherwise we would just be doing 120 divided by 6 and then multiplying that result by 5 plus 9 minus 9. But we need to make sure that the multiplication actually occurs with everything that we're dividing 120 by. So we need parentheses there. And again, make sure it's easy because we're kind of reading this like from right to left. It's easy to think, oh, I'm going to divide by 120. But because 120 comes to the left of what we did in step 3, we need to make sure that the 120 is also to the left of what we're dividing. And then similarly, for the 10, we actually need to make sure that this is what we're raising 10 to the power of. It's not this to the power of 10, it's 10 to the power of this result right here. And so this will be our result in infix notation. Question 4. Okay, so question 4 says convert the following expressions into both prefix and postfix notation. So we're given expressions in infix notation and we need to change them. So let's start with part A. 4 minus 7 times 3 squared. So for prefix notation, let's just again start with what operation is occurring first, and that's the 3 to the power of 2, right? So in prefix notation, that would be written as the exponentiation symbol, 3 and 2. And always make sure to leave ample room kind of on either side when you're starting these, just in case. Next up, we are doing the product of that with 7. So we could write multiplication here, and then 7. So the first thing that'll happen is the 3 to the power of 2, and then we will multiply that with the 7. And then lastly, we need to take this and subtract it from 4. So the 4 needs to come to the left of it to make sure that this is what we're subtracting off and we're not doing this minus 4. So we have to write the 4 here. And then to actually complete the subtraction, we need the subtraction operation. So this 3 to the power of 2 will happen first, then the multiplication, then we're going to do 4 minus that result. So that accomplishes what we have here in infix notation, and we wrote it in prefix notation. Now let's write it in postfix notation. So it's going to be very similar, except just a little bit backwards. So we have to do 3 to the power of 2. And that's done in this other way now, right? Where we write the exponent afterwards. And then we want to multiply that all with 7. So I could write the 7 here, and then do multiplication as so. And then lastly, we want to do 4 minus that result. So we can write the 4 here, and then put the subtraction symbol like that. And we can confirm that we've done this right. So the first thing we do is 3 to the power of 2, because that's the leftmost operation. Then we do 7 times the result. And then we do 4 minus that result, right, with the subtraction here. So that does accomplish what we want to do because it follows the same order of operations that we had in the infix notation. Now I want you to notice something. It's not just as simple as literally reversing the order of everything in the prefix notation. We didn't just write 7, 2, 3, exponentiation times 4 and minus. That wouldn't have worked because, for example, if in our backwards notation we had 2, 3, and then exponentiation, this would correspond to 2 to the power of 3, but we want it to correspond to 3 to the power of 2. So when you're converting from prefix into postfix, it's never as easy as just flipping everything. There are some things that do get flipped. For example, the order of the operations will be backwards, right? Before we had minus, times, and then exponentiation. Now we have exponentiation, times, and then minus. So that will be backwards when you're converting between the two. All right, let's go into part B. So for prefix notation, start by writing what we would start with in the regular order of operations. So that would be this difference here, 5 minus 3. So we do 5 and 3, and then the subtraction comes beforehand. And then the next step we would do is this 9 times 1. So let's write 9 and then 1, and the multiplication of those comes beforehand. Now before we can do this division, we still need to subtract the 8, right? So we got to write an 8 here, and then put subtraction there. And the reason for that is because the 9 times 1 will happen first, and from that result, we're going to subtract off the 8. So that gives us everything in these parentheses, and this minus 5, 3 gives us everything in this parentheses. So now all we have to do is divide the two results, and boom, there is our result in prefix notation. Now to do this in postfix. So again, we're going to start by focusing on what's in the parentheses. So 5 minus 3, we're going to have 5, 3, and then the minus comes afterwards. And then we'll focus on what's going on inside of here. So we have 9, 1, and multiplication comes afterwards. And then we want to subtract 8 off from this. So we have to put 8 to the right of it to indicate that's what we're subtracting off. But then the subtraction also comes to the right of it. Right, so what we've essentially done is we've grouped the 5 minus 3 from the first parentheses, and from the second parentheses we've done the 9 times 1 and subtracted off the 8 from that. So now all that's left to do is divide the 2, which we can accomplish by putting a division operation to the right of everything. So that would be our expression in postfix notation. All right, let's look at the very last part for this. All right, so to convert this expression in prefix notation, what do we do first? Well, evaluating order of operations, we look inside the parentheses, and inside of that, we do the 2 to the power of 2 first. So that's what we're going to start by converting into prefix notation, which we know is 2 2's, and with the exponentiation operator in front of them. Next up, we are going to do 5 minus this, right? That's the next thing we do. So we have to write the 5 in front of them, and we have to put a subtraction in front like that. Because what that's going to do is it's going to subtract the two numbers to the right of it, which is going to be this 5, and the result of this 2 to the power of 2, so that is going to be what we subtract. So now we have everything from these parentheses. Next, what we want to do is we want to do 8 divided by this result. So we have to write 8 to the left of it, because we're doing 8 divided by what's to the right of it, and that will be written with the division symbol. And now we want to add on the 11, and I've kind of run out of room here, so I'm just going to rewrite it down here. So we have 11, and we want to put a plus in front of that because we are adding the 11 with the result from all of this right here. So that will be the result in prefix notation. Now for postfix, same kind of philosophy. We start with the 2 to the power of 2, so that's written as 2, 2, and then an exponentiation. Next up, we want to do the subtraction of 5 minus that, so we put 5 here, right, kind of keeping the same order of the 5 and then the 2 to the power of 2, but then we write the subtraction operation to the right of everything, right, we put it post everything. And then we're going to do 8 divided by this result. So we write an 8 in, and then we write the division after, right? So all of our operations here are just following the order of operations that occur in the infix notation. So to conclude things then, we just need to add on the 11, which we can do by putting the 11 there and adding it to the whole expression, right? Because we're doing 11 plus this entire result. Or if we wanted, we could have written the result that we had from before, put the 11 afterwards, and then put the addition, and that would do the same thing, right? It's just taking this result and adding the 11 to it. And you might like this one a little bit more because then these numbers appear in the same order as they do in the original infix notation, but both work. And for extra practice, make up your own expressions in infix notation and then practice converting them into both prefix and postfix notation.
Question 5.
Okay, so question 5 asks us to convert the expression from prefix into postfix notation. So now we're not going from prefix to infix or postfix to infix or vice versa. We're going straight from prefix into postfix. Okay, so this is starting in prefix notation, right? The operations are all written to the left of the operands that they are being applied to. So how do we put this into postfix? So there's a couple ways we can do it. So method 1 would be basically take prefix and convert it into infix, and then take infix and convert it into postfix. Okay, so let's start with that. So converting into infix first. We start with doing a 10 minus 4, right? The subtraction applying to the 10 and 4. So we'll have 10 minus 4. And then we also have 15 divided by 3. So we'll write that down as well. Right, so we've covered this, we've covered that. And now we're going to be doing the sum of those two things. So we write plus here. And as of right now, no parentheses has been necessary yet because the division will occur before this addition, and it doesn't matter if we do addition or subtraction first here. So that covers the plus part. And then lastly, we just need to do the subtraction of this result. So that's all of this minus 6. And again, no parentheses necessary. So that would be the expression in infix notation. Now we can take that and convert it into postfix. So to convert this into postfix, the first thing we're doing is 15 divided by 3. So we can write 15, 3, and then a division sign. After that, we're adding 10 on. We can write the 10 and then plus, right? Because this result will be added to the 10. And then we're subtracting 4 from that. So we can write 4 and then minus. And then we're subtracting 6 from that, right? So that would be the statement converted into postfix. And keep in mind, there may have been a couple ways you could have done this. For example, maybe you wanted to do the 10 minus 4 first and then add that on. That would maybe make it a little closer to what we were doing in the original statement, but it all ends up being the same thing. So that was method 1. Let's look at the second method, where we're just going to go straight from prefix into postfix. And the way we're going to do that is we're just going to kind of look at each piece that happens, just like we did before, but we're going to convert those pieces kind of on the fly into postfix. So the first piece was doing 15 divided by 3. So in postfix, that is 15, 3, and then division, right? So that is the first piece right there. The next piece was doing the 10 minus 4, right? So in postfix, that is written as 10, 4, and then the subtraction operation. Okay. The third piece was adding these two, right? So instead of putting the addition in front, we're just going to put the addition afterwards. So this gives us our third piece. And then the fourth piece is subtracting the 6 off, which all we have to do is write the 6 afterwards, because that's what we're subtracting off, and then write the subtraction operation after that, because instead of going in front, it has to go in behind. So I prefer method 2. I think it's a lot faster, and there's a lot less kind of in-between work going on where we have to convert to infix and then to postfix. Here, we're just kind of taking it piece by piece like we would have been doing anyways, and then we are converting each of those pieces one by one. So really, if you just take things piece by piece, you can't go wrong when you're doing these conversions. For some extra practice, create some expressions in prefix notation and convert them into postfix notation. Similarly, create expressions in postfix notation and convert them into prefix notation. And if you'd like, try using both of these methods when you do it to get some extra practice. Again, method 2 is going to be faster though.
Question 6.
All right, last question. So this says, identify which expressions are well defined. For those that aren't, what notation should they be written in to become well-defined? So first thing, it says that we have 4 plus 5 in prefix notation. Now in infix notation, right, the notation we're all used to, 4 plus 5, perfectly a-okay. However, 4 plus 5 in prefix notation doesn't make sense because in prefix notation, this plus is applying to the 2 numbers to the right of it, but there's only 1 number to the right of it. So this is not well defined in prefix notation. But if it was in infix notation, it would have been good. All right, let's try part B. So we have 7, 9, and then minus in postfix notation. So postfix notation, right, the operation, it applies to the 2 numbers to the left of it, and it has 2 numbers to the left of it, so this is well defined in postfix notation. All right, part C, it's a little bit longer, and it says it's in infix notation. Definitely not going to be the case because we have a exponentiation right beside a multiplication, and that could never happen in infix notation because this would be combining the 6 and the multiplication, which doesn't make sense, so it is not well defined in infix notation. So then what notation would it be well defined in? Well, it would be well defined in postfix notation, right? We see that the operations always appear after the operators, right? We would do the 2 plus the 11, we would do 3 to the power 6, and then we would do the multiplication. In every case, the operands, or the numbers, come before the operation. The operation is post them, so it's in postfix notation. So it would be good in postfix notation. And lastly, we have this statement, which would not work in postfix notation because we have operations that have nothing to the left of them. And postfix notation always requires that the operations are applied to the numbers to the left of them. So this is not well defined in postfix notation, but it would work well in prefix notation. It would be well defined there because every operation, if we apply it to the numbers to the right of them, we are able to evaluate this expression, right? We do the 9 times 2 first, then we do the 3 plus 8, and then we subtract the result of those 2. So this works in prefix notation.
Concluding thoughts.
Okay, so that's going to do it for me today. I hope you found that interesting. Admittedly, some of these questions were maybe a little more on the boring side because they were just pure calculations or conversions, but it is necessary for us to get practice with them. So in either case, I hope you understand the concepts better now, and I will see you in the next video where we continue talking about some of the interesting ideas that are connected with prefix and postfix notation. So until then, you have a good one, you stay groovy, and I'll see you in that next video.
F.O.A. Maths.